Okay, so what we'll be doing here is we'll set up a metallb and ingress service both. We'll be creating two deployments for HTTPD. Okay, then we'll be creating only cluster IP service. No load balancer service will be there now. Okay, because we don't want multiple load balancers. Then create ingress for both the deployments. This is what we are achieving it here. Cross check that the metallb and the ingress are enabled. If not, enable it. So I'm checking micro k8s status. Okay, so ingress and metallb both are enabled. So suppose we are using any other cluster, and if you want to install no, if it is not micro k8s, and if you want to install ingress and metallb, we'll have to download some YML files, and using kubectl apply we'll have to apply it. But micro k8s made it easy for us. It added it as an add-ons. We just need to enable it. After enabling those add-ons, we'll see ingress and metallb both are enabled. The other method to check would be kubectl get namespace, and in that we'll see metallb and ingress. And again, if you go inside kubectl-n ingress get all, we'll see some pods and services running. Similarly, we can check for metallb. So sometimes for troubleshooting, we will have to see that everything is running properly. Okay, if any one of the pod is not running due to some reason, our exercise may fail, or in production also there will be some issues. Now we are for load balancing micro k8s cluster and metallb can make use of ingress. So what we are doing is metallb is already installed, ingress is also installed, but we need to make aware metallb that we will be using ingress. For that, what we will do is we'll create a service. This is the new service we are creating, and here what we are defining is create an ingress service. So if you see here, ingress get all, there is no service. There is a daemon set and a pod, but there is no service. So now we are creating an ingress service which will use a load balancer. Okay, so it will give one IP address to the load balancer. So remember, there is no service. After applying it, we'll see a service here. So what we are doing is ingress service.yml. Here we are defining ingress type as ingress service as load balancer. Kubectl apply -f ingress service kubectl get all for ingress. So if you see, now even the ingress is having one load balancer IP 1.131. So this will act as a gateway for all the services. Okay, so whenever the request comes to 1.131 on ingress, it will be routed to the other services like cluster IPs for other two deployments which we'll be creating now. So let's create the application. So what I'll do is I'll create a directory mkdir web app cd web app. In that I'll create the deployments httpd web app 1, deployment for web app 1, service for web app 1. Okay, and ingress also we have defined. Now we in earlier step we created service for ingress. Okay, we didn't create ingress for the application. Now we are creating an ingress for application, that is rules of where to forward the request. Okay, so the here we are creating a deployment with httpd image. Then we are creating a service with cluster IP. When we do not define a type here, it will automatically create a cluster IP service. Okay, and now we are creating an ingress rule that whenever the request comes to web app one.example.com, forward it to the web app one service which we created here. Okay, so just apply it, kubectl apply -f web app one.yml. Similarly, we'll create one more, that is web app 2. For demo purpose, even single app is sufficient, but we'll use two applications. kubectl apply -f web app 2. kubectl get all will show the two deployments. Okay, and three replicas are there. So web app 1 deployment and web app 2 deployment created, and two services are also created. Actually, there are only two replicas, not three. So two here and two here. Now on this cluster IP, both the services are available because inside the cluster we can access it on the cluster IPs. Now we want to access it on the ingress level. So kubectl get ingress. Okay, so we have two ingresses, web app 1 and web app 2. Okay, it is showing address at 0.0.1. Okay, but actually it will be available on. So first we need to make the entry in /etc host. These two entries we'll have to add, but for kubectl -n of us to kubectl get namespaces, kubectl -n ingress get all. So this we are saying that whenever the request comes to 1.131, this is acting as a gateway. So we'll add an entry here, vim/etc host. Just remove this problem. These are different. Let's remove this 131. Okay, this is okay. So what we are saying is web app 1 is mapped to 1.131. Web app 2 is also mapped to 1.131. Cat just to curl web app 1. Okay, we are getting the output. Curl web app 2, we are getting the output. Okay, so kubectl get all. So whenever the request comes to web app 1, it goes to this service, and whenever the request comes for web app 2, it goes to the service number 2. And how it is doing that, we have defined an ingress rule. Okay, in that is, these ingress rules are defined here. Route the request to the respective services. So if you make some entry cat/ctc/host, okay, on this VM as well, on this Windows VM, okay, then if we try to access web app 1 and web app 2, then it will be also accessible. So for testing purpose, what we will do is just I have one more VM. I'll just start that VM and we'll make an entry there and we'll check if it is accessible, because on Windows last time also I tried /etc host entry is not properly happening. So in Windows also we can have an entry in /etc host. The host file is different, means at some other location. But for testing purpose, we'll create one more VM in the same network and test it. Till then, if you have any question, let me know. We are almost done with this exercise. We'll just access this web app 1 and web app 2 from some other VM which is not the part of the cluster. Okay, so our VM is ready and I know its IP address. It's 1.12.12. So if you see the IP address is 1.12, it is not part of any cluster, Kubernetes cluster. It is just a VM in the same IP address range. So sudo vi/etc host. I'll make so we made the entry that whenever the request comes to this, it will go to 1.131 and one web 2 also same curl. Okay, it works, and here also it works. If you want to have one more thing, we can check sudo apt-get install elinks is there. So as we do not have a browser, okay, we are using command line. We have a browser on Windows VM, but there it's not easy to make an entry in /etc host. That's why we are testing on command line. So elinks is also kind of a web browser, but for command line. So if I do elinks, it's showing it works. Okay, escape q quit. So similarly do it for web 2. So it's showing it works. Okay, so this was the exercise for ingress and metallb.